Hi, and welcome to this next video on percent of increase and percent of decrease. So this video just goes into a little bit more explanation about types of percent of decrease and percent of increase. So one thing we usually see percent of decrease associated with is a discount. So we see it a lot in retail pricing. So the example that we did before was grades, and so we see it there. It can go either way, percent increase or percent decrease. However, one of the terms that we use in the retail industry or in shopping for percent of decrease is a discount. Okay, so when something is discounted, then that means that it's decreasing in price. So let's look at the first example, or look at this example. A book bag is on sale for $9.05. So, and it's down from its original price of $25.40. So by what percent has the bag been marked down? Well, a bag is on sale, so we know that the sale price is always the final price, and the original price is always the initial price. So remember that it's final minus initial over initial compared to percent change over 100. So what we're looking for is the percent change. We're looking for, in this case, the percent change is actually the discount. Okay, so to do that, we have to find the difference between the prices, and so we can do that by subtracting the initial from the final. So if the final price is 19.05 cents and the initial price, the original price, was $25.40, then we can find that change there. So what is 25.40 subtracted from 1905? So I'll give you a second to pause and do that. Okay, and it looks like we should get negative $6.35 over $25.40. So we remember that we were calling our discount X in this case, so we want to find out what the discount actually is. And so since a percentage is always compared to 100, 100 will be what our percent change is compared to. So we have now, once we've simplified our equation, we have negative 6.35 times 100 and X times 25.40. So negative 6.35, that'll just come out to be negative 635, while we have 25.40 X. So now let's divide by 25.40 in order to find out what X is. Okay, go ahead and take a second and do that. Okay, and what I got is negative 25, and so the discount is 25%, or you could say the price went down 25%, or you could say it's decreased by 25% in brackets, meaning that it's in the red. Okay, so it's a decrease. Okay, so now let's look at situations where we might have a percent increase. Well, in retail, we normally see a percent increase whenever we are applying a markup. So we're going from wholesale to regular price. So the wholesale is the price that the store pays. So wholesale is price to vendor, or the person that we're buying it from, and the retail is the price we, as in the customer, pays. So the price that we pay, or the price that the customer pays. Okay, another place you see percent increases in sales tax, or tax in general, right? Of course, you pay a percentage. If you have sales tax in a country or in a city, then you apply the sales tax by multiplying whatever your value or your total cost of items is by percentage and adding that to whatever the total cost is. So let's look at these two situations to apply this. So a store pays $79 for a CD player, which it then sells for $144. So in this case, our original price is the lower price because that's what the store bought the item for. So this is our initial, and the final price is what they sold it to us for, or for the customer. So that is the final price. So what is the percent markup? So how much is the store profiting? What percentage of the price is the store pocketing for their revenue, okay, or for their keeping. Okay, so we have the final, remember, minus the initial divided by the initial is equal to the percent change over 100, and we can call our percent change X. Okay, so let's go ahead and find it first. So the final is 144.30 minus 79, which is our original, divided by 79 is equal to X over 100. Okay, so let's go ahead and calculate what 144.30 minus 79 is. So 144.30 minus 79 is equal to 65.3 divided by 79. So that means it's positive because the original price is less than the final price, right? So we should have a positive because it's increasing. It's a markup is equal to X over 100. So let's multiply that and see what we get. So we have 79X is equal to, that'll be 6,530. So let's divide that by 79, divided by 79, divided by 79. And so X in this case, so the percent increase will be 82.65%. That's what I got, 82.65%. Okay, and of course the way you can check that is to plug it back in, but for the sake of not making the video too long, I'm going to go to the next problem so that you guys see enough examples. So what will the customer pay after 8.62% sales tax? So the customer bought, so now what's happening is this is a two-part problem. So what did the customer buy the item for? Well, the customer price was, if we look back, $144.30. So that's the customer price. Well, what we're going to do is add sales tax to that. So in this case, we're given the percent change. We know that the percent change is going to be 8.25% because we know that that's being applied to the customer price. Well, what we have to find now is the final price because that's what we're missing. So the customer price is now the original price in part 2 of the problem because we're going from what it actually costed the customer to what the customer actually paid in the end. So the original, remember we call the initial, not O, sorry, I'm going to use the I because I don't want you to get it confused with 0. So that's the initial price. The final price is what we're missing. We know the percent change to be 8.25%. Okay, so let's set up our proportion. We know we're going to have 8.25 over 100. So when we put it over 100, we can drop the percent. And so the final is what we're missing, minus 144.30 divided by the original price, again, $144.30, because it's always final minus original. Well, now notice that we're missing a variable, and so we don't have a nice little easy problem that works out. We actually have to do some algebra in order to find x, but we continue the same process. Remember that we always cross multiply so that we can solve for our variable to get us an equation that's equivalent on both sides. So we have 100 times, well, remember that this is a hidden parentheses because this is a part of a fraction. So it's going to be f minus 144.30 is equal to 8.25 times 144.30. Okay, so now what we have to do in order to solve this, well, we can't move f until we distribute the 100. So we have to distribute the 100 to both terms in the bracket. So that's going to be 100f minus, well, when we distribute 100 to 144.30, it becomes 144.30 without the decimal place because we just moved the decimal place over twice. And so now we just have to multiply 8.25 times 144. So go ahead and do that. Pause the video. Okay, so I got 1,190.4, it's 0.475, but I'll go ahead and use 0.8. So 1,190.48. Okay, so now what I'm going to do is, in order to solve for f, I have to get rid of 14,430 by adding it to both sides. So plus 14430 plus 14430. Make sure all of your decimal places line up correctly. Okay, so now these will cancel and I'm left with 100f. And so now I want to add both sides. I want to add the 14,430 to that side. So that gives me 15,620.48. Remember that. And then now I'm just going to divide by 100 in order to solve for f. So I'm going to divide both sides by 100. And so f is equal to, well, all that's going to do, if I divide by 100, yes, you can go ahead and divide it out, but I can tell you what it's going to do. It's going to move your decimal your decimal point 2 spaces to the left. So that will be 156.20. So your numbers won't change, but your decimal place will be moved 2 spaces to the left. And because the 48 is going to be so small and it's not going to cause us to round up, we'll just stop at $156.20. And since we're talking about money, we should round to the nearest hundredths place, which is the nearest cent. And so the customer will pay $156.20. And if we check back, that makes sense because we know it should be more. So if the original price, right, I keep using the word O, but if the initial price or the original price was 144.30, it seems pretty reasonable that increasing the price by 8.25% will cause it to go to $156.20. Okay, so I know this is a little new. These problems were a little more challenging than the problems in the last video, but of course you can go back through this video as many times as you need to, but you need to be able to, one, find the percent change, but you also need to be able to use the percent change in order to find a missing value, either a final price or an original price. Okay, so I hope this video has helped. Practice this as many times as you need to, and look back at these videos as needed. Alrighty, see you in the next video series.